Welcome to the Heat of Vaporization demo. In this lab, we will be determining the heat of vaporization of water. We will do this by heating two identical beakers with different amounts of water on the hot plate. We will measure the change in temperature of the more full beaker during the time it takes for the less full beaker to vaporize. This will allow us to calculate the amount of energy needed for the water to vaporize. Let's take a look. To start, we are going to be putting 100 milliliters of room temperature water in one beaker and 5 milliliters of room temperature water in an identical beaker. Next, we are going to quickly place both beakers on the hot plate and watch carefully for the first sign of the 5 milliliter sample to begin boiling. Once it starts to boil, we will record the temperature of the 100 milliliter sample as our starting temperature. Here, our 100 milliliter sample is at 25 degrees Celsius when the 5 milliliter sample begins to boil. And now we wait. Here's some music for you to enjoy while you watch water boil. Once the 5 milliliter sample has almost completely vaporized, make sure to pay attention to the temperature of the 100 milliliter sample. Once the 5 milliliter sample is completely vaporized, record the temperature of the 100 milliliter sample. This is your ending temperature. Here, our ending temperature is 51 degrees Celsius. We now have everything we need to complete our analysis. First, we will need to use the specific heat, Q equals MCAT equation, to determine the joules of energy transferred to the 5 milliliter sample during vaporization. We can do that by calculating the Q for the 100 milliliter sample. To do that, simply multiply the mass of 100 grams by the specific heat of water and then by the difference in ending and initial temperature. Once we have determined how much energy was transferred to the 100 milliliter sample, we can use that for the joules in our heat of vaporization equation, since both beakers receive the same amount of energy. That's it.